This video goes over lesson 3.5 and it covers how we find the measures of the interior and exterior angles in triangles, as well as how that's related to the parallel lines that we've been talking about throughout this unit. The triangle angle sum theorem is a very useful theorem in geometry. All triangles have the same angle sum. And that sum, so the sum of the measures of the interior angles of a triangle is always exactly 180 degrees. So in my picture here, there are three interior angles in the triangle. If we take the measure of angle A plus the measure of angle B plus the measure of angle C, that is equal to 180 degrees. We can prove the triangle angle sum theorem using properties of parallel lines. I've mostly filled the proof in for you, but I want you to see how this works. This isn't something that you need to know for the test or anything, but it's a great problem. So in our triangle ABC, I've created this line N that passes through point C and is parallel to AB. So here's line N. Let's draw a little N there. And we want to prove that the measure of angle 1 plus the measure of angle 3 plus the measure of angle 2 is equal to 180. And notice that those angles right here, 1, 3, and 2, are the interior angles in our triangle. All right, so first off, every proof starts with a given. Here I've just listed the information. In triangle ABC, line N passes through point C and is parallel to line AB. Next, we can see that angle 1 and angle 4, so these two angles right here, they're a pair of alternate interior angles, and we know that when two lines are parallel, alternate interior angles are congruent. We can also find another pair of alternate interior angles with angle 2 and angle 5. So I put those on the same line because both of them use the alternate interior angles theorem. Okay, next, the measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 5. That's using the definition of congruent angles. I need them to switch to the measure of so that I can do substitution in the next couple steps. Okay, line 4 is using the angle addition postulate. So notice that 4, 3, and 5, together 4, 3, and 5 are making a straight line. So by the angle addition postulate, if we add those adjacent angles together, they total up to the straight line, which is 180. So now here's where the magic happens. We are going to do some substitutions here. So notice that in this angle 4 is the same as angle 1. Similarly, angle 5 is the same as angle 2. So if I make a substitution and I trade angle 4 for angle 1, and angle 5, I trade that for angle 2, we just use the substitution property. And now we have exactly what we needed. Angle 1 plus angle 3 plus angle 2 equals 180. The next theorem talks about exterior angles of a triangle, so we need to make sure that we understand the difference between interior and exterior angles. An interior angle is an angle formed by the sides of a triangle. An exterior angle is formed by one side of a triangle and an extension of an adjacent side. So in our picture, notice how there's this extension of the side and then angle 1 is outside the triangle. That's an exterior angle. And then the remote interior angles are going to be an interior angle that is not adjacent to the exterior angle. And by not adjacent, think not touching the exterior angle. So in our picture here, if my exterior angle is angle 1, notice how angle 3 and angle 2 are interior angles, but they're not the one right next to, which touching angle 1. They're the other two interior angles. Those are called remote interior angles. And in any triangle, the measure of each exterior angle is equal to the sum of the measures of the two remote interior angles. So in our picture here, the exterior angle is angle 4, the one that's outside the triangle, and then the remote interiors are the two interior angles that don't touch the exterior. So there's my remote interior angles. Using this triangle exterior angles theorem, we would say that the measure of the exterior angle, which is measure of angle 4, is equal to measure of angle 1 plus measure of angle 2. So in words, that's exterior angle equals remote interior plus remote interior. Now that we have all of these theorems, right, the triangle angle sum theorem tells us that the interior angles in a triangle always add to 180, and then the triangle exterior angle sum theorem tells us that the measure of each exterior angle is equal to the sum of the measures of the two remote interior angles. We can use these two theorems to find missing angles in triangles. Let's go ahead and look at some examples. For example 1, I have all interior angles. Notice that there are no exterior angles, there's no extensions, okay? The first thing that I see in letter A is that, we have our interior angles, and using the triangle interior angle sum theorem, we know that the three angles inside the triangle need to add to 180. So if we add up the two that we know, 62 plus 83 is 145. So x plus 145 has to equal 180. I'm going to subtract 145. So that's x equals 35. In the next triangle there, notice that we have kind of two triangles going on. I'm going to start by focusing on this triangle. So let's add up the two angles that we know. Here I'm not going to make an equation, I'm just going to add them together. So 57 plus 59, if we add that up, that is 116. And I need my total in that green triangle to be 180. So let's take 180, subtract 116, and when you calculate that, that will be 64. So x here must be 64 degrees. Now, notice that this 64 right here, there's going to be another 64 here because those two angles are vertical angles, and vertical angles are always congruent. So now if I move over to the second triangle, so we look at this triangle here, let's add up the two angles that we have. 42 plus 64 adds to 106. And then I'm going to subtract that from 180. 180 minus 106 equals 74. So y must be 74. For this next triangle, we can see that it's also made up of two triangles. I'm going to start with this triangle over here because I have 2 out of the 3 angles already. So I'm going to start at this pink triangle, and let's add up the 2 angles that we have. So if we add 35 and 96, they add to 131. And then I need the total to be 180. So let's take 180, subtract 131. And when you do that, you get 49. So x must be 49 degrees. Now we need to also find the y. And for the y, there's definitely a couple of different ways that we could do this. But I want to draw your attention to the fact that there is like an outer triangle here. So if I look at this triangle, kind of the outside triangle, we have two of the angles right now. We have a 77 and we have a 49. So 77 plus 49, and then y and 35 have to be the other angle. So plus 35 plus y has to equal the full triangle 180. Now, just add your like terms. You can take your calculator and add those three numbers together, and that's 161 plus y equals 180. I'll subtract 161 on each side to get y equals 19. For our final example here, notice that the triangles both have exterior angles. So I know it's an exterior angle when it's outside the triangle. So we have an exterior angle over here is x, and in the second picture, the exterior angle is 104. Remember, by the triangle exterior angle theorem, the exterior angle is equal to the sum of the remote interior angles. So remote interior angle 1 plus remote interior angle 2. Okay, so I'm going to make my equation. So my exterior angle, x, equals the two remote interiors are those two right there. So 54 plus 57, add those together, and when you do that, you get 111. So x is 111 degrees. Now, our last question over here, we have the exteriors, and these two are the remote interiors. But it's always, remember, exterior equals remote interior plus remote interior. This is the formula that we are using. Exterior equals remote interior plus remote interior. So the exterior is the one I want by itself. So 104, that's my exterior, has to equal the remote interior angle 1 plus the remote interior angle 2. So 104 has to equal x plus 49. We can subtract 49 on each side, and that's 55. So x equals 55. And this concludes lesson 3.5. You're now ready to practice finding some missing angles in triangles on your own. Thanks for watching, and good luck as you practice. Bye.